So this is another video in the series Build LLM from Scratch. So today we can talk about encoding word positions. Okay. So in the last video we talked about embedding tokens. Okay. Here we'll encode the word positions because in a LLM the transformer actually works in parallel. It processes the tokens or words in parallel. So we need to keep track of the word embeddings, word positions. Okay. So embedding layer, what they do is they convert IDs, the token IDs, into vector representations, right? So here, so if there are two, for example, if there are two IDs with the same two identical token IDs, they are converted to identical embedding. Okay, so here is an example. So for example, we're trying to encode this or embed this token IDs, a series of this token IDs 2352, right? So here the positions are different, right? So this 2 and this 2, this both are going to be encoded as the same embedding vector. Okay, so you can see here this because it's looked up from the embedding weights matrix, which is this one, and as you can see, this 2 corresponds to this embedding, and this 2 corresponds to this embedding, and they both have the same embedding vector, right? So now we cannot tell the position. So we need to keep track of the position. Okay, so let's see. Now positional embeddings are combined with, so what we do is we already have done token embeddings in the previous video. So in this video we can do positional encodings, and these two, the token embeddings, are added, right? The token embedding is added to the corresponding positional embedding. They're added element-wise. And then they form the input embeddings, which are fed to the LLM. Okay, so let's see. The byte pair encoder, which we're going to use, right? So it has a vocabulary size of 50,257. Okay, so there are a total of 50,257 tokens, total unique tokens. Okay, when we use byte pair encoder. Okay, so now if we want to encode the input tokens into a 256 dimensional vector, so we want to embed, right? Each of these tokens, we want to embed them. So when we embed, so let's say we want to embed in a 256 dimensional vector representation, right? So so we have this vocab size, which is 50,257, right? And then the output dimension means each one of these tokens is supposed to be 256 dimensional vector. We want that to be so. Okay, so that's why so we put 256 here. So here we're embedding, right, just like we did before in the previous video. So we do torch.nn embedding vocab size by output term. So this creates the token embedding layer. Okay, so so what this does is it will create so we will have access to, or this creates let me show you this kind of embedding weight matrix where 50,256 tokens. Okay, these rows are the tokens, and each token is converted to 256 dimensional vector, right? So so each of these rows it has vector size. The vector of each row is 256. Okay, so here this is the embedding weights matrix. This is what we get. Okay, so now if we want to if we sample data from the data loader, we embed the tokens in each pass into 256 dimensional vector. So for example, now we have this embedding weight matrix, right? So now let's try to embed one batch, right? Batch of our input data. Okay. So for that, we can use, say, a create data loader, this function, create data loader v1 function. So here our max length is 4, right? So and then here these are the we're passing these parameter values, right? Arguments, and then so we create this data loader, and then we can iterate through it. So iter data loader. So this is this mix it in data iterable, okay. And then so when we call next on that iterable, okay, so what we get back is the inputs and the targets, right? Input in the targets of the, so one batch, okay. Let's say the first batch, okay. So these are the inputs and targets in the first batch. Okay, let's see what they look like. So for example, here, okay, here we see that the token IDs, the inputs, so these are the in the first batch, okay. So the first batch we got here, okay. In that we have these, these are the token IDs, right? So there are total of 8, right? So okay. So because our batch size is 8, so there are 8 tokens. I mean, 8. The size of the batch is 8, right? So there, okay, 1, 2, 3, 4, 5, 6, 7, 8, right? 8 rows. So again, these make up one group, right? And then these 8 groups, let's say, and then each of these have 4 tokens in them. 1, 2, 3, 4. So that's this max length, right? So it's 8 by 4. So this is one batch, right? And the shape of that is 8 by 4. 8 rows, 4 columns, and these are the targets. Okay. And then let's see. Now token embeddings is equal to token embedding layer input. So now here what we do is we take these inputs, not this one, right up there. So take these inputs and we want to embed these. Okay, we will try to embed this this batch right here. Okay, so now so that's how do we do that, using token embedding layer, which we created right up here. Token embedding layer, which is this one, right? Which I showed you here. So this will, provide us with this one, embedding weights matrix. Okay, and then these tokens are looked up from there. Okay, these tokens are looked up from there. Okay, all right. Okay, so now, okay, so we get the token embeddings. The token, these tokens, this not this one. This one is embedded. Okay, embedded. So what's the shape of the embedded output? So here is the shape of the embedded output, 8 by 4 by 2056. Okay, so that means, so we provide this one batch to the embedding layer, right? And it does this lookup on this embedding weight matrix, and each of the tokens are converted to, they fetch us these. Every token is, is converted to 256 dimensional vector, right? So here, after embedding, we'll have 8 by 4 by 256, because each token is going to see each of these 4. There are 4 tokens here, right? So each of these 4 tokens will be converted to a 256 dimensional vector. So that's why we have this the third dimension here. Okay, and then let's see. Okay, so now GPT-2, which we're trying to build right from scratch. Okay, it uses absolute position embedding. So we just create another embedding layer. So here we can so here we have the context length equal to max length, right? And position embedding layer is equal to this context length. Okay, and we're creating this embedding layer. Okay, and then here positional embeddings is equal to here we're creating this positional embedding layer. Okay, with this for the position. So torch.a range max length. Our max length is 4, right? So max length with 4 means we're gonna have there will be 0, 1, 2, 3, right? So this will give us 0, 1, 2, 3, and they are supposed to be the positions, right? 0, 1, 2, 3 are supposed to be the positions, and they are embedded, okay? And we get 4 by 256, right? So each of the positions is converted to a 256 dimensional vector, right? Okay, so now what we're going to do is, as we saw previously, so as we said, we're going to add the token embeddings and the positional embeddings, right? So that's what we're doing right here. Okay, so right here, let's see where it is here. Okay, so these token embeddings are added to the positional embedding, right? So okay, token embeddings are added to the positional embedding, and then we have a torch sizer 8 by 4 by 256. Okay, 8 by 4 by 256. Okay, so now okay, let's put them together. Okay, so now let's start from the beginning. For example, we have this input text. This is an example, and this is tokenized. Okay, like this, and tokenize, every token is converted to token IDs, right? And these token IDs are converted to this token embeddings, and then the positional embeddings, right? And these two are added, these correspondingly, the token embeddings are added to the positional embeddings element wise, and we get this input embeddings. And now we're ready to input this into the zippity, okay, this transformer. Okay, all right, thank you.